So in this exercise, we need to show that norm 1. So this is the norm 1 of a vector x in Rn divided as follows. The sum of the absolute values of the entries of x, and this one define a norm on the vector space Rn. Recall that a norm is just a map from the vector space to the set of non-negative real number, such that the norm of each vector in the vector space must be non-negative, and it is 0 if and only if the vector is 0. And for any scalar alpha in any vector in the vector space, the norm of alpha times v is absolute value of v, absolute value of alpha times norm of v. For any two vectors v and w in v in the vector space v, the norm of v plus w less than or equal to the norm of v plus norm w. So triangle inequality. Yeah, so our job is to check the three conditions are satisfied. We prove that this norm 1 defines a norm. On Rn. So condition 1. We show that we call the norm 1 of any vector x in Rn, so is greater than or equal to 0. With the equalities if and only if vector x is vector 0 in Rn. So we have norm 1 of x by definition is either sum upon I from 0 to I from 1 to n. Absolute value of xi absolute value of xi, that's by definition here. And because absolute values of any number is non-negative, so this sum will be non-negative. Really true for because xi is a real number. Okay, and norm 1 of x equal to 0 if and only the sum of xi from 1 to n 0, and this if and only if xi is 0 for all I. This is the reason because this absolute value of x is non-negative. Absolute of xi is non-negative, and this is 0 if and only if they are all 0. And absolute of x equal to 0 if and only if xi equal to 0. Okay, so condition 1 is done with the condition 1. What is condition 2? For any scalar alpha, for any vectors x in the vector space Rn, we will show that norm 1 of alpha times x equals we will show that alpha times norm 1 of x. This all must be norm 1. Okay. The left hand side is norm 1 of alpha times x. Norm 1 of alpha times x, so this is norm 1 of vectors alpha x1, alpha xn transpose, because we work with column vectors only, norm 1. And now by definition, this is sum of alpha xi, which is absolute value I from 1 to n, and the sum of this equal to alpha n times xi. This alphas is just a scalar that does not depend on any I, so we can take it out. Sum from I from 1 to n xi, and this is alpha by definition. Absolute value of alpha is still the same, and the rest is the sum of the norm of x, norm 1 of x, which is the right hand side. So condition 2 is satisfied. If we not say comfortable with this notation, we can just write them all in terms of the sum. So this in terms of alpha 1 x1 plus alpha xn, right? This one equals this one, and alpha x1 is absolute value alpha times absolute value of x1 plus absolute value of alpha times absolute value of xn. This is in fact absolute value of alpha times absolute value of x1 plus xn. By definition, this keep the same, and this is just the norm 1 of x, which is the right hand side. Condition 3 is a triangle inequality. So now let's pick any vector, say x and y, in Rn. We have norm 1 of x plus y. By definition, this is sum from 1 to n xi plus y, and call that in we have triangle inequality before. This absolute value, and this is less than or equal to n absolute value of xi plus absolute value of yi. Yeah, so that is just properties of absolute value. It satisfies the triangle inequality for that. And yes, by definition, this is norm 1 of x. So let me write one more step. This is absolute value, the sum of this, sum of absolute value of yi. Definition, this is norm 1 of x, norm 1 of y. So condition 3 is satisfied, and therefore this defies norm on Rn.